Hi, so today I'm going to basically go over how to do classification with Python and Keras using the iris dataset. So iris dataset, commonly known as Fisher's iris dataset, basically is pretty commonly used for a lot of basic classification problems within machine learning. And it's essentially 4 attributes featuring information about flowers, as well as what type of species of flower they end up being. So basically, I'm just going to start by going over, in case you don't already know, the difference between regression and classification, just to give a high-level overview. So regression, it's a typical type of question that you might be asking: what is the temperature going to be tomorrow? So you use historic data, and you're going to be able to essentially predict a numerical attribute. Classification, on the other hand, what you're trying to do really is predict a categorical attribute. So if in this example, will it be cold or hot tomorrow? So regardless, you're using a number of factors, and then you have a target variable, an output variable, which is your response. So basically, in our case, we're doing something called multi-class classification, which is the output could be a number of things that is more than 2 classes. It could be a number of species of flower, of the iris flower. So that's what we're going to try to understand. So we're going to start by really importing some packages and functions that we need for this. And we're going to obviously use Keras, which is a deep learning library, like I said, as well as pandas, which is really useful for manipulating data, scikit-learn, and scikit-learn will really help for evaluating our model as well as preparing our data for the modeling procedures. So we'll start by importing all these libraries. And then our next step is really to load our data and take a look at what we're dealing with here. So essentially what I'm doing here is I'm listing out the names of the columns that I want, and I'm using pandas. I'm reading in a CSV file from a URL link. And then we're going to view a little bit about the data set as well. So we see here that we have our 4 attributes and our target variable. So our 4 attributes are sepal length, sepal width, petal length, and petal width. And then our class, which is essentially our target variable, is the species of flower that we're trying to predict, that we're trying to classify using these other attributes. So we now want to really sort of shape our data and put our data into a form that we can actually be able to feed it into a machine learning model. Our goal here, just like any machine learning model, is to map a function x to y being our class and x being all of our numerical, or in this case numeric, but all of our predictor attributes that we're using to try to essentially figure out what species flower we're dealing with. So using pandas, we go a bit more and actually end up partitioning out some of our data set as x and another part of our data set, another column, as y. And we want to find out, okay, so let's find out what our variety of different species of flowers are. Okay, so we see here that we have Iris setosa, Iris versicolor, and Iris virginica. So we're trying to classify, using our other attributes, which one of these species of flower that the observation predicts, essentially. So we have 3 different class values, but we really need to reshape our output attributes to become a matrix with a Boolean for each class value. So what I mean by this is we want to do something essentially a little bit of linear algebra where we're doing something called one-hot encoding. So we don't have much time here, but essentially, in a high level, we're creating a matrix that tells us whether or not a row of data has a particular class value, has a particular species or not. So in order to do that, we leverage the scikit-learn library, and we use something called label encoder. That's the function that we use. And then from there, we're going to also, essentially change our encoded values of integers into a one-hot encoding matrix format using a Keras function called toCategorical. So essentially, we go ahead, run that, Control Enter. This is Jupyter Notebook, by the way. And then from there, what happens is we're going to go ahead and actually, because we're using Keras in this example, we're going to define our neural network model. So essentially, within Keras, and this is Keras, by the way, you can find it on keras.io. Essentially, it's a very easy way it's a high-level neural networks API. It's built on TensorFlow, and it's a very easy way to construct neural networks from scratch. And really, if you're wondering what a neural network is, essentially we're feeding our input and we're mapping a function that goes from input to output. But the reason neural networks are so popular is because they're able to deal with nonlinear complex data. So that's what we'll be essentially working with here. So we're going to essentially use something in Keras called Keras classifier, which in the scikit-learn library is used as an estimator, which is essentially a model that is a predictor. And we're going to create a very basic neural network, and our main goal here is to classify what type of iris flower species that we have. And essentially what we're going to do is we're going to create a simple, fully connected neural network, essentially one-to-one neural network. And we're going to have one hidden layer and 8 neurons, so pretty basic. And our hidden layer is going to use something called an activation function, and in our case it's going to be called ReLU. So the purpose of an activation function is simply, so each of our nodes in our input layer is given a particular weighting, okay? And then we add bias within a neural network such as this. But in order for this weighting plus bias calculation to actually introduce some sort of nonlinearity, we use something called an activation function. There's a few of them. There's sigmoid, ReLU, tanh, and they're all essentially functions that are able to convert output into a different type of output that is able to be fed into subsequent nodes, particularly in more complex neural networks. And essentially, our output layer in this case, we're trying to create 3 output values. So one for, well, not necessarily in this case, but one for each of our classes. And why is this? It's because we're using one-hot encoding. We're trying to find out what species of flower that we're essentially dealing with. And so, in conclusion, 4 inputs, 8 hidden nodes, 3 outputs, and then in our output layer, we're going to use something called softmax. Softmax is another activation function, and in this case, it's going to transform the outputs to have values between 0 and 1. And then from there, we have predicted probabilities that are generated, and then from there, essentially, our goal is to use the highest probability to predict what class is associated with a given row of data. And this might be a bit out of the scope of this tutorial, but just to explain, we're also going to be using a gradient descent algorithm called ADAM and a logarithmic loss function called categorical cross entropy. And really, it's going to really help in terms of our processing as well as the performance of our neural network. And these types of hyperparameters are really important later on in order to pick carefully. So our baseline model. So we're defining a model object as sequential, essentially saying that we're going to define it in order. And then we begin with defining our dimensions as well as the activation functions that we're using. Then we compile our model. So if you remember earlier, I said we're going to have essentially 4 inputs, 8 hidden nodes, and 3 outputs. So what this is saying is, okay, so our input layer is going to have a dimension of 4, and we're going to incorporate 8 hidden nodes in a dense layer. And then we're going to use an activation function called ReLU, like I said before. Our outputs, like I said again, will be 3 outputs, essentially, 1 for each class, and we use an activation function of softmax. And then we compile the model using this type of loss function, this type of gradient descent optimization algorithm, and the accuracy we want, or the metric that we want to see to assess the performance is simply called accuracy. Okay, fair enough. So we run that. And now, we're essentially going to be passing some arguments to our Keras classifier in order to fit our model, to train it. And essentially that's what we're doing here. So we're defining Keras classifier from scikit-learn. For using within scikit-learn, we define our model object that we defined earlier, epochs, which is the number of iterations that a model is going to essentially train, batch size, how many at a time it will train, as well as verbose. And verbose essentially says we're going to turn off or turn on debugging, and in this case we're turning debugging off. So then we continue, we evaluate our neural network. So let's run this, and then we're going to evaluate our neural network. We're also going to define our model evaluation procedure. So we're using something called k-fold cross-validation, and this is essentially a train test partition method that prevents something called overfitting, which is essentially bias within our model. So we go ahead, run that, and now we're just going to pretty much go ahead and run our model. We're going to see how it performs, and we're going to get our evaluation metrics that we want. So this will take a little bit of time, but essentially we're splitting our data here into 10 different parts, and then each time we're taking one part of it as a test or validation data set, and the other 9 parts as training, and we alternate essentially. So this ensures generalizability. It's really important. Although I can't really go too much into depth in this video, I've already gone over time. The main idea is within machine learning, within a classic machine learning model, you divide it into training, a data set into training and testing or validation. And the purpose of the training is for the model to simply, the algorithm to understand the patterns of your data. And then testing is essentially when you're actually in a new way predicting unknown data to assess the performance. And here what we achieve is we achieve a baseline accuracy of 88.67% with a standard deviation of 25.31% in terms of our model accuracy. So what we've done is we've loaded our data, we've made it available to the Keras deep learning package, we've prepared classification data for modeling with an emphasis on using one-hot encoding procedures in order to actually be able to classify what species of flower that is being classified. We defined a model object and then incorporated it with scikit-learn, and then essentially we then ended up evaluating our neural network, training it and then evaluating it, and then we incorporated the use of k-fold cross-validation to prevent bias and overfitting. And hopefully you learned something from this. Essentially, the main points, if you try to get anything out of this, is that we used the iris dataset, which is essentially involving flower measurements in order to classify the type of species of flower. We did a classification problem, which essentially is predicting the categorical attribute, which in our case is the species of flower. Keras was a deep learning package that we used throughout this to essentially build our neural network. And then from there we used scikit-learn to go forth, do cross-validation, train the model, evaluate it. But of course we needed to beforehand inspect our data, encode our data to make it fit within a model setting. And our key question here, our key data science question here that we were trying to answer is how can we use these 4 attributes to predict the species of flower? And that's what we've managed to be able to do with an 88.67% accuracy. So this is a little bit of an overview. Sorry I've gone a bit over time, but hopefully you've managed to pick up something at least from this video. Until then, see you next time.